happy. I'm happy that you're all here and managed to come. I'm very happy that people are still coming in, and I look forward to seeing that we'll be lacking chairs in the auditorium. That will be one more indicator of the success. I'm also happy to hand over to Ruslan, who is the local and general chair, and I believe he will tell you a few things about what will be going on, in which order, where to have coffees, and the rest. Ruslan, the podium is yours.
Thank you, Vadim. So we have an agenda for today's. All participants are grouped in sessions by topic. Today we will have the first three sessions in natural language processing, applications of AI 1 and applications of AI 2. At 12 p.m. we will have a lunch break for 1 hour lunch break. And at 3 p.m. we will have a coffee break in a lobby on the first floor, which is covered by the master's program. Yes, so the procedure to present is pretty simple. We have a Zoom link, and we join the meeting and leave computer audio and start sharing the screen. We have a camera here, microphone, and yeah, so each slot is 20 minutes. We have 15 minutes to present and 5 minutes for questions and answers. I really encourage everyone to follow the schedule and to we will try to keep everyone fit in these time slots. So in 15 minutes after you start presentations, we will tell you that you're out of time and we should switch to questions and answers. If there will be more questions, I encourage you to remember them and ask during the lunch or coffee breaks. Or one more thing which I didn't mention, we also have 5:30 p.m. we have a social event. Also encourage everyone to join. So this is pretty much it. Good luck everyone, and I think we can start presentation.
One more bit. Could you please present the session chair?
Yes. Yes, so today, session chair. Yeah, so sorry. The session chair for today is Professor Vadim Ermolayev. I would say the founder of Master Symposium and the chair.
Together with Alexei Molchanovsky.
Yes, the chair for many years in a row. So really glad to have Vadim here and organizing this event.
Thank you, Ruslan, for a very kind introduction. And well, we're still a little bit ahead of time. You have 7 minutes to grab your copies if you wish. And we will start at 900 German time. German time, just because they had announced that they did not switch to spring hours this year.
So
luckily, we will be having the same time as in German.
You may also try to join the presentation if sharing is working, if sound is working, also within this 7 minutes.
And you know who is the first to present? Yes. So let's go ahead and feel free, ask someone to bring you coffee. Yeah. Enjoy 7 minutes left before the start. Yeah, that's it.
So what is a paraphrase? And the paraphrase is a reformulation of a sentence that preserves meaning while changing wording or structure, as you can see on the example on the slide. And this can be handled pretty easy by humans, but this is the point where the NLP systems may fail on. And paraphrase matter for at least 4 reasons, and they are: the first one is data augmentation, probably the most important one, because if we can generate valid paraphrases, we can enlarge training data with semantically equivalent examples, and which may help models to generalize better. The second is a semantic evaluation. So paraphrases let us test if the model is sensitive to surface wording. The next one is adversarial testing. Here we intentionally create semantically preserving perturbations and test the model weaknesses. And finally, it's a robustness measurement. So we measure if a model changes its answer or prediction or reasoning when only the wording changes, so it's probably not robust. And here is the way to paraphrase to be a natural test for NLP systems. So Ukrainian is not among the low resource languages overall, but it's still under-resourced in terms of paraphrase benchmarks and robustness-oriented evaluation resources. So this motivates 3 goals for us. The first one is to build a high-quality Ukrainian paraphrase dataset and benchmark. The second goal is to train a model using that data. And the final is to use the resulting data to test the robustness of Ukrainian-oriented language models. So here's a brief history how paraphrasing evolved through time. So it started from the statistical machine translation methods, especially the pivoting idea. Here's the idea to translate a sentence through some intermediate language and then recover it in alternative expression. Then we moved to sequence neural models, where text represented continuously and generated token by token. This was a major improvement in flexibility, but still lacked of control. The next stage introduced some control paraphrasing, where researchers tried to guide the models to make some special paraphrases by using predefined templates and special tokens. Then we moved to general LLM era, where the big and vast models, they see a lot of data, so they are capable of doing paraphrases by its own. And finally, a very relevant idea for us is meta-learning and adaptation, which is particularly a LAPA framework. Their contribution is to treat a paraphrasing as an abstract skill that can be learned in one context and adapted in the other context. And in the original setup, the context was a domain shift, but we believe that we will try that same logic for the language shift from English to Ukrainian. So briefly about the evaluation metrics. So it started from blue and raw scores. They are overlap based. So we compare n-grams between 2 texts, which is output and our reference. And because they came from the machine translation, they kind of limited for paraphrasing, because they assume we have a gold reference where we compare our similarity to it. But for paraphrasing, we may have a few outputs that are still valid, and they are like preserve high semantic similarity and low overlap or diversity. That's why the later works, they introduced like a separate metrics for diversity and semantic similarity. First one is a self-flow, which is just like checking if the input and output is not the same. That's for diversity. And then next metric is a BERT score or similar embedding-based metrics, where we compare the similarity in the vector space. And of course, there is a very general approach, LLM as a judge. And for robustness testing, we have a paraphrase consistency metric, which measures if the model like output, probability and generations and reasoning still consistent if we change the wording of our prompt or input data. So our framework here has 3 connected parts. The first one is a data creation step. So we'll build a Ukrainian paraphrase dataset from multiple sources. Then we will use that to train a model using a LAP idea for cross-lingual transfer of paraphrase skill. And this Third part is the robustness testings, where once we got a validated set for paraphrases and the paraphrase generator, we will use them to evaluate the Ukrainian LLMs. In general, we can describe this as we build the data, we train a paraphrasing system, and then we use that to robustness evaluation. So about the step number one, which is creating a data source, our biggest, probably the most complex work will be a news clustering idea. We believe that there are different media that report the same events in different words. So it actually is natural paraphrases that came from the humans, and we may cluster them by looking for those that are semantically equivalent or they were published close in time. So the second source will be a back translation algorithm, which is very simple. We just sample Ukrainian sentences, translate them to some intermediate language, and then translate them back. Of course, we'll use some LLM paraphrasing to broaden our distribution of data. And the fourth source is an existing corpora, which is particularly SQ after dataset. This is most recent dataset for text editing in Ukraine, and it has a subset of paraphrasing tasks, so we'll use that also. And after all those pairs, we do not treat them as valid instantly. We will do some robust pipeline, again, for semantic similarity, for lexical diversity, the duplication. For news, we will run some kind of publication window filtering probably, and so on. Then we will get those data and try to build the model. And our hypothesis is that a language gap can be handled similarly to domain gap as the original paper. And we will use some multilingual sequence-to-sequence model. We will insert some lightweight adapters into it, and then we train two steps. The first one is a meta-learning phase, where we try to learn the abstract skill of paraphrasing in English language, and then we run fine-tuning on Ukrainian validated data set. And we will test that on three different setups. The first one is a pure model fine-tuned on only a Ukrainian data set to test how it works without meta-learning and English. The next one is we using a model then doing a meta-learning in English and trying to adapt Ukrainian on top of that. And the last one is again the comparable Ukrainian paraphrase model, which is a large model. It was trained on the that previously mentioned Spivautor dataset. It's just an external baseline for our tasks from the community. So in this work, we will define robustness as a semantic invariance. And that means if the input is paraphrased, but the meaning remains the same, the model output, distribution, prediction, or reasoning should be the same or stable. And for those tests, we propose two tasks. The first one is semantic equivalence identification. It's actually very simple. So we directly ask the model if the two sentences are paraphrases. We collect the answers and calculate the accuracy score. And the second one is more complex and robust, we believe. So we'll create so-called consistency buckets. It's buckets where we have a set of prompts or inputs that have exactly the same meaning, but phrased differently. And we will run them through the model and check the outputs. So the model should behave consistency across all of them. And in this case, the PC score will be identifying the percentage of paraphrase pairs that lead to consistent prediction in our case. So about our preliminary results, we did a data construction stage. So we got 22 million of news items. We made some initial clustering and filtering and got some 15 million candidates pairs from that. And again, this is a still high level candidates. We need to run more robust filtering for extract near duplicates for where one sentence is much longer than another one that we treat as a context expansion and so on. Of course, we already set up some back translation and the LLM paraphrasing, but from those, as you can see already, the back translation examples, they are pretty close in their output, so they do not introduce a lot of diversity as we hoped before. So we will see if we'll include that in our final validated data set. And our roadmap for the future work is that we finalize in dataset filtering for this next week, then 1 more week for running a human validation on a selected subset. After that, we train our models and check their performance. And the final week, we run robustness experiments described previously. So our expected final output are the following. So first we create a training paraphrase dataset and human validated benchmark. Second, we train some adapted paraphrase models based on those data. And finally, we run robustness evaluation and present those results to quantify sensitivity of Ukrainian focused large language models. So thank you for your attention. Now I will be happy to answer your questions.
Thank you for saving us 4 minutes to start the questions. Are there any questions, ladies and gentlemen?
Yes, please. Have you tested two steps translation or 3 steps, not just to English and reverse, or for example, to English to Chinese?
We haven't tested it yet, but we have it as an idea because those actually do not work for us as we expected. So we'll probably try that also, like some multiple intermediate languages.
More questions? Okay, I have one a little bit more conceptual. You mentioned meta-learning.
Yep.
Your meta-learning in the context of this work is more or less like within the scope of one particular task. Meta-learning in many papers is more like multitask learning. How much multitask is your meta-learning?
So we want to be consistent with our original papers that we, our main reference. They call the meta-learning as a first abstract step to learn the tasks, which is abstract skill. So we call it like meta-learning for one particular task, but we treat it as an abstract skill.
But it's not meta-learning. To be consistent with the paper you cite. Because the paper you cited says that meta-learning is a skill of abstraction to abstract between different tasks, using priors to learn one task and adapt to a different task, isn't it?
Oh, yeah.
So your meta-learning does not adapt to a different task. It does adapt to a different context within one task.
Yes.
So I would suggest to avoid calling it meta-learning.
Okay.
So, but it's just a suggestion. You may call whatever, whatever, but you have to explain the context. And more questions? No. Any questions from the virtual participants? No. I noticed briefly that in one of the previous slides, in the context of systematic robustness framework, you mentioned LAPA and you mentioned MoMA.
Yep, that's probably the
For cross evaluations, for example.
just to get the robustness evaluation for both of them because they are most.
Could you please elaborate a little bit more? How do you plan this cross evaluation experiment? Using LAPA, using MoMA, how to compare?
So maybe it's a bit confusing. We do not plan the cross evaluation. We just want to run evaluation separately on LAPA model and on MoMA model because they are probably the most robust right now for Ukrainian language. So we want to test them independently.
You do not plan to compare the results of these two evaluations?
Yeah, we can publish them and check which is better, but it will just two independent experiments.
Okay. Sounds odd a little bit for me. You have both. You have chances to compare the results and say that MoMA, for example, is much better than LAPA or vice versa. In the experimental setting, having this benchmark and having this framework, the having set measures. Why not doing that?
It's a good idea. I'll probably add that to our plan.
Yeah, this is one more practical result that you that can put on the table. And this will increase the impact of this work. Yeah.
Also, I have a question, maybe about the future steps. I don't know, how do you anticipate, I don't know, the development or usage of the benchmark designed by you? Are you going to publish it somewhere, make it accessible to everyone, or I don't know, somehow popularize it so that other researchers can adopt it and test it?
Yeah, we'll definitely do that when we get some like good results, probably after human validation step. But yeah, that's probably our main idea, to develop and publish that.
Yes, and maybe you could also please elaborate a little bit more on your ideas on how are you going to perform the human evaluation. Maybe you have calculated how many annotators do you need, or do you have some picture in mind how you're gonna do it?
Yes, so we'll probably sample those paraphrases from different sources that I mentioned. So our news mines, source number one, then LLM paraphrased and back translation source. Then we will like remove this mark for source, shuffle them, and ask our like annotators to evaluate them on probably three metrics. The first one is semantic equivalence. Do they preserve the semantic? Then the lexical diversity. Do they introduce a lot of diversity to be treated as a paraphrase? And the final probably will be fluency. So does this sentence like a valid sentence in our language? Because, for example, when we translate, or sometimes the LLMs, they generate not very fluent sentences. And for now, we do not calculate the expected like a number of samples to be statistically like, powerful to measure the whole our data set, but we will do that.
Mm-hmm. And maybe a follow-up question: is this like human evaluation framework? Should it be like custom for Ukrainian, or maybe it was already done for other languages and you can adopt the rules and you know, maybe tools that were used for labeling such benchmarks? Or
so from what we already like researched, there are the step of a human validation is almost always a last step where just we filter out all the not very good paraphrases and we got only the most probable ones, and the humans need to just say yes or no. And because like the sample size of the data set, they are sometimes really huge, and all the annotators, they cannot answer the like 3 or 5 questions on every pair. So in our case, we will not run on a huge number of examples, but we will try to make it more broader evaluation, as I say, probably on 3, maybe some other metrics. But yeah, we do not like adopt any other ideas of human evaluation. We just will create our own.
I see. Thank you.
Just to elaborate a little bit more on the previous question.
1 minute.
Yeah.
Actually,
in fact, 0 minutes, but very short question. How do you plan to avoid human bias in this human evaluation?
So we'll probably ask a few annotators, and we will compare the results between, then we can merge them together, check the marks and check the distribution for different probably sources, and check if there is actually a difference in the evaluation for different sources, and if there are statistically significant difference, so we can treat it as valid evaluation.
To have an estimation of the networks for human evaluation?
Yeah.
Will be huge. Next to unrealistic, I would say. So thank you very much. Our next speaker. Who's our next speaker? Then it's time to come out to the session. Our next speaker is Mykyta Berehulia, who's going to present his work entitled In Domain Term Distillation Using Contrastive Classification. Mykyta, please connect, and the floor is yours.
Yeah, 1 second, please. Yeah, hello everyone. Today I will be giving a topic on the subfield of the natural language processing, which is called automatic term extraction. This project was done together with Professor Vadim Ermolayev, and I would like to acknowledge the help and the consultations and review that was provided to me. The talk structure will be pretty standard. We will start from the basic motivation, why this is a problem and who's interested in solving it, except of us. And we will formulate and try to formalize the problem statement, see how which tools we have to solve it, and the research framework overall. We'll try to apply this framework to the solution and the results we already have, and we will discuss how further it can be investigated and analyzed. So why do people want to extract the terminology? So going from the lower level to the higher, specific terminology from the specific domain might be valuable for the building the knowledge graphs, and these knowledge graphs are next used in binary symbolic data. So the knowledge graphs themselves are quite popular right now. They have been highlighted in the Gartner reports. They can contribute in different areas. The main issue that they require a significant amount of time to define the ontology, connect different entities, and this is a huge amount of work. And these people need the high quality data being provided. Yeah. If we will start thinking on how this is done right now, so the most obvious and classical way will be to take the huge corporal text and your text that you need, from which you need to extract data, and try to compare them according to, for example, different frequencies. If the specific term is more frequent in your set of the documents, but less frequent in general corpora like Wikipedia or British corpus, that means that it seems to be more specific to this domain. The idea that we are introducing to simplify this approach and make it more efficient, that you don't need to extract, you don't need to compare the data with general corpora. You can compare it with just smaller contrastive corpora, and that this output will be more efficient than the output provided with general corpora. Why it will be more efficient? The main idea is that when you're performing such comparison with general corpora, you will definitely extract a lot of noise. So, for example, you are having a heart disease domain, and you would like to extract heart disease specific terminology from this set of domain text. And you technically may extract other terms that don't belong to the heart domain, heart disease domain, but still are rare and occur rarely in the general corpus. So idea that if you are taking two distinguished corpuses, that domain-specific terms will meet in them rarely, and that you will be able to clearly distinguish between them. That it's not 100% distinction, it's like relative, but expectations that our results will be better than that. Yeah, so we see this problem So we actually see the terminology as 6 categories, where the first will be the domain-specific terms. This is something we are actually interested in. So from the third disease corpus, we would like to extract something like left ventricle ejection fraction. So this is highly specific terminology that next will be used to build the knowledge graph or something else. We have broader domain terms. We are less interested in them because this can be considered as a noise. Plus, they are not very specific to this domain, but they are highly present in the text we are extracting data from. We also can have out domain terms. These are also rare terms, but they do not belong to the domain we are interested in. And we have common sense terms. This is a basic words. We have named entities, which also need to be removed, and non-terms, which is pure noise. Yeah, here is an illustration of that. So if we will try to illustrate this is for her, this is the main. So yeah, we are going from more specific to less specific, from left to right. So the main idea is that we are not able to blindly select two contrastive domains. We need to have some logic between them, and this logic is we formalize it as a distance between domains. So they should be close enough terminologically to each other, so they have no false negatives, but their distance between each other should not be too far away, because in this way they will start fail to filter broader terms. So how this distance between domains can be measured? There are multiple ways. For now, we split this into groups: statistical measures and embedding-based measures. So for statistical measures, there are already known approaches like weirdness index, overlap ratio, chi-square, TF-IDF also potentially can be used for that. But we also would like to visualize these domains in the embedding space and see if there is a relation between them and how it can be utilized to solve this problem. As a benchmark, we have used the Hector dataset. Hector is the annotated corpora for term extraction research. So these are 4 domains that were manually annotated by experts and shared with audience to exactly perform a benchmark of this task. So for early results, what was done? We have performed statistics. We have calculated basic statistic measures. As the contrastive corpora was used for actor domains, as a general corpora was used Wikitext with 2 million of tokens. As extraction tool, it was used the already existing pipeline to extract terms from the text and remove everything else. It extracts just general terms without, it's not extracting exactly specific terms. And next, different methods was used to compare frequencies, and different methods was used to process multi-word terms, because multi-word terms are special handling. We can search for phrase inclusion. We can try to take frequency of a specific word in the term, or like average, min, max of product. So from what we observed, the main parent matters for contrastive filtering. So if we are comparing, for example, corruption corpora with heart failure corpora, the results will be different if we are comparing corruption to some different line energy corpora. Still, general corpora outperforms contrastive in 2 or 4 domains. In one of them, they perform equally. In one of them, they perform better. But the key difference is that all these contrastive corpora are much smaller than Wikitext, and due to that, we can assume that to perform such comparison, we don't require such big corpora as Wikitext. This is a bit of details about the actor. So which terms does it have? So it has the annotation in the data set, and it also has the text corpus as is, as a raw text, which you can use to extract them, extract terms. Below we see the terms extracted and their scores. So the higher score seems to be, it's higher chance that this is a term. And yeah, these are first results for the statistical comparison. So with general corpora, we can see that in two cases we have outperformed funnels. In one case, we will have equal performance, and in one we have outperformed. Taking out from the contrastive comparison, we can see technically that for some domains it works better for others, and we can also see that the domain version is asymmetrical, and depending on the selection domain, we may receive different results. Yeah, this is an attempt to illustrate these corpora in the embedding space. So small embedding model like LLM term was used to visualize this. Next dimensionality was reduced with UMAP, and we can see that there is a clear pattern that domains are grouped into clusters. These clusters are overlapping. So on the left side, we see all terms extracted, and on the right, we see only the specific terms extracted. So we actually want to draw a boundary between right side domains. And we can see, for example, for specific of them, we have a distance bigger than for others. So for example, for heart failure, we have a bigger distance between heart failure and corruption is bigger than distance between computation and line and everything. The idea is to utilize this in some way and give additional have additional insights for building the domain distance as a to formalize it. So currently we have completed the initial contrastive experiments. We have started to work on the semantic relations in the Latin space, defining the domain distance, and for future it's planned to evaluate this on the additional domains, not only on these four. This is still a complex task because creation of such domain might be complex task, and yeah, formalize the domain selection for such task. Yeah, so as a conclusion, we can see clear benefits for specific domain pairs. We see that the relation exists. We would like to investigate more deeply in the different paradigms on how we can perform a comparison. And yeah, we are setting the future trajectory for formalizing domain selection. From my side, that's it. Nothing else. And proceed discussion.
Thank you very much. I have a conflict of interest with this. So the questions are obvious. Any questions? Please. Yes, again.
Maybe I missed something, like you can separate this domain and evaluate if they are different or not so, or what?
The purpose that we need a clear in-domain terminology for building a knowledge graph. And these knowledge graphs are actually built manually by experts. And the problem is that they need to extract and annotate domain knowledge they have and build an ontology and relationships between these terms. And the problem is that even creating a list of these terminology is a huge work. And if we would like to do this on scale for different domains, for different experts, we need some tool that will provide us an ability to quickly give as input, for example, a huge set of scientific papers and get terminology from there. And we are highly confident that this is the terminology we actually need without different noise and without additional data cleaning and so on.
I believe he answered on to a different question. So the question, just to paraphrase the question using the opportunity of listening to the versatile. Question was, why do you need a contrastive domain? For what? Was it the question?
Why we actually need the contrastive domain? As I said, if we are performing comparison with the general corpora, we are receiving a lot of noise because in the such domain-specific text, there might still be terminology not only related to this exact domain. So as we have been talking about heart diseases, in heart diseases we can have a general medicine vocabulary and other stuff that we actually want to filter out from there. Hopes this was the right answer to that question.
One more paraphrase. Why do you need to compare different domains?
Compare different domains. What do you mean exactly?
You mentioned a pair. For example, this heart disease and wind energy.
Yeah.
Why? Why do you need wind energy to find something for heart disease? Why do you need to compare those two domains?
This is a still open question how to select the best pair of the domains for comparison. But the main idea is that we need to select such domains that do not have a disjoint in terms of domain-specific terms. And
So
not too far away.
Speaking normal language, and then sorry, without disjoint and the rest. If you have heart disease, they use their specific terminology. If you have wind energy, they use their specific terminology, and this terminology is not overlapping. There's no heart disease in wind energy. So to separate and distill the heart disease terminology, specific terminology, you have to see what is specific for it. And the specific will be is the terminology that you cannot meet in wind energy, for instance. That will be a specific for heart disease and vice versa. But the general terminology like time, space, the rest would be met here and here. So this is the way to filter out this common terminology or less specific term. That is the idea. Am I correct?
Absolutely.
Sorry for interpreting your work. Yeah, go ahead.
Do you use some existing data set or you are creating your own manual?
Yeah, we have an existing data set that was published in 2020. It was a few times updated. Actually, the main task of this project is not creating an additional data set, but we also have one more that we plan to add this comparison. So there should be 5 of it.
This is it. You have a question?
Yes.
Yeah, it will be a very last quick question. 1 minute to go.
Yes, I have 2 quick questions. What are you considering a term in this case? Is it one word, multi-word combination? This is the first one. And the second one, what are maybe the other ways to for term extraction except contrastive comparison? Maybe I can just feed the data set to LLM and ask, give me the terms, or maybe what are the other ways for term extraction?
So for answering your first question, terms in our case are n-grams that have high level of lexical specificity, and they can be multi-word terms. So it can be a single one, but it can be also bigger. Actually, the chances that there is higher chances that multi-word n-gram will be a term, specific term. In terms of how it can other ways except this, yeah, people are doing a lot of research in this way, but results are still mediocre. There are a high level of subjectivity in what do people define as a term, which leads to the inter-annotator, pure inter-annotator agreement for such datasets. So yeah, it can be done, but it's still not the most optimal approach. Okay, thank you.
Thank you very much. Our next speaker will be Markiian Matviiv with the title efficient Guardrailing for the Ukrainian LLM via recent installation.
Questions. Great. So, hi everyone. My name is Matviiv, and today I'm presenting to you my master's thesis expose titled Efficient Guardrailing for the Ukrainian LLM via Reasoning and Distillation. And I'm proud to share that this research is conducted in a strategic partnership with the Ministry of Digital Transformation of Ukraine. So today I will share some motivation behind the need of having a sovereign AI infrastructure, existing problems, research questions, and methodology of solving it, some interesting early results, and roadmap for future work. So let's start with the context. So in today's turbulent and global geopolitical landscape, and especially during our full-scale war, AI becomes a strategic asset for national security. So for Ukraine, which is building a national LLM, it's a matter of digital sovereignty. This model should master not just our Ukrainian language, but also understand deeply our cultural, historical, and war-related context. So for the Ministry of Digital Transformation, which use large language model, their government services like DAI and a few more that are coming in the nearest future, is quite important to solve a few technical problems. It's minimizing the latency for real-time processing of data, solving like a problem of low resource consumption, so it should be budget friendly, and of course it should be highly accurate. There are a few fundamental challenges to achieve that. First one is vulnerability to semantic attacks. So current existing guardrail systems developed by Western companies like Lombard, for instance, from Meta, they often lack, often show a low effectiveness in detecting region-specific threats. So they oftenly falsely flag some legit discussions of war-related topic, marking them as violence. At the same time, they oftenly miss hostile propaganda completely. The other one is the inflexibility of taxonomy. So those guardrails operate on rigid, predefined categories, and it's quite hard to extend them and customize for our specific needs. The third one is computational inefficiency. So those massive generative models with billions of parameters becomes a bottleneck because every single request you need to process twice, and actually you are throwing your system twice, and it's quite expensive to maintain this infrastructure. So to solve this issue, we have two research questions. The first one is, can a compact specialized encoder model achieve the same accuracy as big generative guardrails, but having a small, less than 20 millisecond latency? And someone can a small linguistically specialized encoder model outperform a larger multilingual model in detecting this region-specific threats, for instance, propaganda. To
To verify those hypotheses, I used a dataset provided by the ministry. It includes real prompts from DA users and their some internal safety benchmarks. The data was divided in, for this POC, it was divided into three categories, three classes. Safe, to be legit questions and prompts, harmful, a combination of prompt injection, jailbreaks, hate speech, and so on. And the third one is the hardest one, is propaganda, divided by design into separate category because it will show us whether our model really understands the context. So for basic training, we used two models. The first one is Super Roberta, a small but smart model, 125 million of parameters. It's trained specifically on Ukrainian corpus, and the second one is MD-Berta, is twice larger and multilingual model, but based on the BERT architecture as well. For baseline comparison, we used a few, one of the most popular and industry standard guardrails to compare the result with those SOTA models. So as you can see, after some zero-shot fine-tuning, the results in terms of efficiency is dramatical. For instance, Roberta takes only 9 milliseconds to process a request. In comparison, Qwen and Shield models took almost 500 milliseconds. Even Llama, which was the fastest of them, took 77 milliseconds. But as you can see, for the accuracy, it struggled a lot, especially for detecting propaganda. So it's almost 0, 6% only. And our encoder models achieved a great result. So successfully detected all the propaganda samples in the test set. But this fantastic results seem to be too good to be true for such a basic fine tune. So we suspected that encoder models just memorized some typical lexical triggers like I don't know, Nessis or junta, other typical propaganda words. So we decided actually to make this test harder. We used JAMA model to completely rewrite this test set, strip away all those explicit lexical triggers, but preserve all the malicious intent behind of them by masking them with some techniques. And as you can see, the result was quite different. Guardrail's models basically collapsed. So now the Llama didn't detect like any single propaganda sample at all. And even Qwen, which was the smartest one of them, showed like mixed results. And even our encoder models struggled. So Roberta dropped from 100% to 55 in detecting propaganda. And it basically confirmed our theory that there is a generalization gap with those basic fine-tuning. And to address that, we decided to shift the training paradigm. Instead of just putting labels on raw data, try to enrich the latent space with additional details and decision-making logic of larger models. So we focused on two, like, in some similar, but at the same time different approaches. The first one is adversarial contrastive distillation technique, which actually require you to generate triplets of data. So for same data sample, you generate a positive paraphrase, and hard negative. So same words, but completely different meaning. And then you force your model to mathematically move this prompt vector like away from the hard negative and closer to hard positive. The second approach, second method is rationally aligned distillation. So you need to like use your teacher model to generate an explanation, explicit explanation why this prompt is safe or is dangerous or why it's propaganda. So after fine-tuning models with those approach, you can see that results are quite interesting. So rationally method improved Hooker-Berta model quite much, but at the same time MD-Berta degraded. So it confirms our theory that linguistic alignment is like more important than the model size. And for contrastive distillation, results are much better. So for propaganda detection, you can see that we actually doubled our result. And it makes this method like the most promising in future research. So, like in conclusion, we successfully validated our two hypotheses. So efficient, so encoders can rival large quadrilles with having a really small latency. We actually revealed that there is a generalization gap, and it's a problem of training, not the architectural limitation. And as I said, contrastive learning technique is a highly viable direction for future research. And roadmap for the next step is actually to expand our classification to 8 categories. It was discussed in this ministry, and we defined those categories. Increase the data set, and try actually to combine those methods and maybe achieve even higher results. And the final step is actually to provide the ministry all the research details, the training pipelines, benchmarks, and integrate these models into their infrastructure. So that's it. Thank you for your time and attention. Happy to answer your questions. Thank you very much.
I don't have any conflict of interest to this paper, but anyhow, please go ahead and pose your questions. So, yes,
You mentioned 20 milliseconds environment.
Yeah.
From where did you get it?
So it's from the ministry. Like currently, LLM is their LLM at least is streaming the response token by token, and so you can see the response landing for you. If you have like higher latency on your guardrail system, you actually cannot do streaming. You need to receive the full response from the model, process it once again, and for the user, in terms of user experience, it's like not the best way to make them wait, I don't know, 10, 15 seconds without showing any results in the process.
More questions?
Yes. So, do I understand correctly that the baseline models that were chosen for comparison were evaluated zero shot?
Yeah.
Okay. And maybe the next question is, for example, right now you are testing those ideas on 3 categories. Let's assume if I want to integrate more categories, like what should I do? What should be the procedure? And yes.
So technically, the one of the goals of this research is actually provide a full training pipeline where you can like customize these categories, customize this data set. There are a lot of generation process of this explanation parts of the data set. So the idea is to provide like provide some automation for that. There are a lot of manual work, and those pipelines that I'm building actually should solve this problem at least in some part.
Okay, so some kind of recommendations and maybe paths how to actually design and train a model. Do I understand correctly?
Yeah, so like the methodology, some recommendation, and like training pipelines, actually scripts where you can just modify some parts of it and automate this process.
And maybe another question. So, do I understand correctly that your data set is consists only of Ukrainian language? Right?
Yeah, so for this POC, yes. So we actually try to verify whether it works for Ukrainian language at all. But the end goal is to have actually 3 languages that we should discuss with the ministry: Ukrainian, Russian, and English. Because DIA should, maybe not should, but actually it does support these languages for the.
Thank you.
More questions? Well, what I like in this work is the confirmation that adversarial contrastive distillation works here and works there. So there might be a good clustering between 2 topics, and you may wish to talk to each other to find out if there is a way to further optimize here or to find ideas for measurements there.
Yeah, and also paraphrasing.
This is not about paraphrasing.
No, paraphrasing. There is some similarity as well.
Yeah, sure. Well, what I wanted to ask is this enough?
For a POC, probably yes, but not for the final goal. We just need to verify the direction. Is it like we moving in the right way or not? Should we change something or continue?
So I do believe that if you increase this one, well, by 2 orders of magnitude, the results will be much more smooth in terms of its fluctuations and different measurements.
Yeah.
In different ways of training the system. Yeah. That would be a good way to find out what is the optimal size of these fine-tunes.
And experiment with different languages, as Xwan said as well.
Yeah, this comes further. It might be good to see if being trained on Ukrainian would be beneficial for the Guardrailing to be quicker trained on Russian police.
Actually, I have some results that have been done after preparing this part of expose. And even having such a small data set of 6,000 and specifically in Ukrainian language, it showed quite high result in existing guardrails benchmark designed for English language only. So I was surprised that we got.
Do they have multilingual benchmarks?
English only. So it was.
That could be a good proposal to extend to multilingual.
Yeah. So the other agreement with the ministry is to provide for them manually human written benchmark as well, like for 50 samples of each of 8 categories that we agreed to.
Okay, thank you very much. Our next speaker is Bohdan Ruban. With Yurii, Paniv, and Dmytro, Chaplynskyi sitting somewhere in the back.
Mykhailo.
Mykhailo, yeah, I'm sorry. Mykhailo, Pavliuk, and Veronika Solopova, multilingual LLM-based content narrative generation. Well, sorry for missing.
That's okay.
No, it's not. Please go ahead and close it.
Hello everyone, my name is Mykhailo. Thank you all for coming. So I'm presenting today a research that I have co-authored with my thesis advisor Veronika Solopova, which is titled Multilingual LLM-Based Counter-Narrative Generation Against Disinformation. That's still a working title for the final thesis, but it's a bit long. So let's get started with the plan. Today we will talk briefly about our motivation to do this research, background and current state of things, and what kind of research questions do we have, how do we answer them, and the problems that we are solving. Then we will move to the planned approach and solution. We will have a look at the methodology, at the pipeline of this research. We will also have a look at some data examples, and on our evaluation framework. Then we'll get to early results and conclusions and wrap it up with a quick Q&A. So our motivation for this research is that right now social media and different news sources are a contested space. This is also not the entire truth, is it? Because it's not isolated places that we go to kind of get our news and then tap off for today. Because I could also argue to say that all the space around us is informational and it is contested. It's contested by journalists, news publishers, investigative agencies, governments, different organizations, and well, they're all contesting to make us believe the stories they are telling. It's not all like big government propaganda or huge political campaigns. Sometimes it's just ads, marketing, salespeople. But they all have a similar goal, is to make you believe what they are saying. And they also label all of their stories as truthful. This is simply not possible because there are conflicting sides of stories. So publishers that are responsible enough to do so employ moderation for the content that they publish. And some traditional approaches to moderation include detection of harmful content or disinformation and removal of that content from the platform. It's fair to say that fully human conducted moderation is not able to keep up with the news cycle in this time. So naturally, there have been some automated moderation techniques, which also brings us to a task of counter speech, which is an NLP-based task of responding to misleading or harmful content with some clarifications, with arguments, with facts, to try and provide alternative and often subjectively correct point of view, often not. The asked for. Which brings us into the background of these researchers. So prior work has demonstrated that it's feasible to use automated counter speech. However, it has been mainly used in terms of hate speech and toxic comments online. So it's not really that well researched within political propaganda or disinformation on some global events like, I don't know, COVID, global warming, and stuff like that. We also have a lot of established NLP research that focuses on this thing called narrative extraction and framing, which is good at breaking down texts in various actors and assigning a certain label to them, like a villain, a hero, or an innocent, or a victim, to help us better understand like what their motivation is and why are they in this story and what is their role. Veronika, my curator, has also authored some works that investigate recurrent narrative patterns in disinformation and how effective they are at swaying people, how believable people find that. And also in 2025, a research paper and dataset called Polynarrative has been released, which introduced a multilingual, multi-domain dataset with this narrative extraction, which had a cool abstraction that basically split narratives into fine-grained and coarse-grained, which was a big inspiration for our work as well. And in general, counter narratives and counter speech that goes beyond English language gets increasingly more popular, but it's still limited to a specific selection of languages like Spanish, Basque, Italian, and Greek, which was a bit surprising to me. And lastly, we also have prior work that shows that LLMs encode systematic bias when generating text, and which leads to beliefs that there may be some faulty training data that may not have been vetted well, and maybe some procedures need to be reviewed. So with all of this in mind, it looks like we have also tools necessary to create and systemize an automated counter-narrative generation, try to apply it in multilingual context, try to rise above just a simple claim and comment level debunking, and create some kind of a bigger framework. So this brings us to these questions that we'd like to answer in this research. I apologize for repeating myself. Can we rise above climate comment level debunking? Because we have all seen that online. Maybe like in Twitter and community notes, sometimes there's disinformation post and there is just a response that says, well, actually, no, it's not like that. So sometimes it can be a bit like what about them, or may not look believable. Another question is performance in multilingual environment. Can we achieve the same quality of generated counter speech in English and in Ukrainian or German, for instance? Another question is how to evaluate that efficiently. We are going to employ both human annotators and LLM as a judge for evaluating this data. But they all have their own faults because human annotators involved like attitudes towards political propaganda, and LLMs, as we know, may hold some bias from their training data. Also, there is a risk of dual use and some ethical concerns that we also investigate in this research. Because if LLM is able to generate counter narratives for disinformation story, it probably can do it so for the truthful story. So we look at how eager LLM is to do that, not to try and optimize propaganda generation, but just to find out and document this. Which brings us to our methodology. For the basis of this research, we used dataset from EU versus Info research, which consists of article text, article link, label, which is disinformation or truthful. It's all pulled from their EU versus Info database. And we use it to do two tasks, basically. At first, to deploy some large language models locally and generate this narrative level, so to split each article into individual claims that we can use to debunk them, to extract entities who's the hero, villain, or victim from the story, and also to provide base narrative and broad narrative. Base narrative is something that explains why do these claims belong in this story, what is the story about, and broad narrative is something overarching, like how is the story, how it is embedded in current like political climate or what else is it related to. And once we have that, we proceed to counter narrative generation. So this step is also done using the locally deployed large language models. And basically we provide complementary entities to what we have in the extraction layer. So we counter broad narrative, counter base narrative. We also rebut each individual claim, and we reframe entities. We also provide some comments on what is the strategy used in this generation. As for the models used for this research, we landed on Gemma 9B, Llama 8B, and Mistral 7B. The reason for that is all of them are rather small models and can easily be deployed locally to test them. And they are all labeled as multilingual. So they have been trained in multiple languages. We also looked at some other models, but we can tell more about that in the thesis. For this experiment, we have run through extraction layer and split into narratives and entities. around 1,500 articles. It's pretty balanced data set. It's skewed towards this information because we also have truthful articles in here. So we performed this extraction for multiple languages, 5 to be precise. And then we have downsampled it to 250 articles, 50 for each language, each processed 3 times. So that's 750 data entries in total in this data set through counter-narrative generation pipelines. So the reason for that is because we wanted to evaluate each model, how well it generates counter-narratives. And we have employed student researchers and ourselves to evaluate our results. Obviously, as students that have been evaluating German or native German speaking and native Ukrainian speaking, so I'm able to evaluate Ukrainian data. Basically, everyone evaluated the language that they are at least like C1 level. We have also employed 3 different models as judges. We opted not to deploy them locally for this task, but rather just used current state-of-the-art API models. So that would be DeepSeek, that would be GPT 5.2, I think, and that would also be Claude Sonnet 4.5. Let's have a look at the data example. So in our data set, we have a lot of different disinformation articles. Some of them are subtle, some of them are not subtle. So this example is not subtle. So basically, headline of this article is "Pogrom in Uman over Shabbos. Ukrainian thugs attack Jews were evacuated to the hospital." So this is labeled as disinformation. So it means that it has been debunked on the EU versus Disinfo database at some point. And it speaks about a conflict in Uman between a local man and a man of Jewish heritage, which ended up with local man calling his anti-Semitic friends, and they have been chasing around Jewish people with clubs and knives from witness claims, basically. So people who already know this disinformation, they can very clearly tell that this is about this article, but people who already hold some beliefs that maybe there are some people who are anti-Semitic in Ukraine, maybe it's systematic, they can be persuaded by this kind of emotional language. So let's just have a look at what we have extracted here. So model has obviously identified Jewish people being victims and Ukrainians as violent because that's what the story is found. So base narrative is that there has been a violent attack. It highlights need for self-defense. And broad narrative is, yes, it's dangers of anti-Semitism, failure to protect minorities. And we have one claim, usually it's like 5 to 10 claims per articles, but the claim is 30 Ukrainian thugs attack Jews with knives. And our reframing strategy is to emphasize the complexity of this story, because we don't really know if it was anti-Semitic, right? It should have just been a conflict. There's no simple good versus evil framing. So we appeal to the fact that it's still being investigated. We can have all the details. And also, while the incident has appeared and it's bad, we should not generalize and we should promote understanding. So this is how we approach this. It's pretty generic, but I have to also say that we generated both counter narratives and narratives using zero shot. So it has been a prompt which was rather generic. And all of the models have produced similar results, but still different. So for evaluation, we had these metrics. We chose these metrics to be able to judge if our output is quality, so if it's persuasive and seems credible, and also if it's complete, if it's relevant, if machines like stay on track of the story, if not diverge and stuff like that. We also employ 2 categorical values during calibration to use them in further prompt refinement. This is a spoiler of early results, which is not in the expose, but which will be in thesis. So this is for distribution on how humans and large language models evaluated our results. It's all mixed, so it's all languages, disinformation, and truthful articles. And we can see that also somewhere the scores are similar, but we can see that for completeness, for example, humans were a lot more gracious with their scores than LLMs. LLMs had completely different evaluation approach, and for persuasiveness as well. So we can see that these 2 things that we can say the models generally struggle, and this is what we aim to improve in our further research. So to conclude, models can be used to extract narrative structure from multilingual news. They can be used to generate these counters, and we know that they can produce this information as well as counter false news. Performance difference across languages, and it looks like models can be used to support human in the loop disinformation detection workflows, but their scores are inherently different than humans. Our plans for the next further this research is to do some prompt tuning, to expand the data set to include more languages, to include increase the sample size in each language, and that would be it. So thank you, and I will be taking up.
So, do I have questions? I feel you've had a lot yet. Okay.
So, I think you mentioned that the same way, the same logic can be used for vice versa to generate actually disinformation and propaganda. So, have you considered maybe not disclose or not share publicly some of your research because our enemies
Yeah.
have it?
Yeah, we have. I mean, they obviously are included in the dataset. I have to say that first things first, most of the articles are from like 2019 to 2022. So that propaganda may not be as impactful, and we have drastically reduced the size of truthful articles that are being evaluated. So we might just drop them from the final dataset. So yeah, not to reach any like ethical concerns.
Good. Operations. What would be the contribution of your thesis?
Contribution would be a data set, because here we build on the basis of article, text, and label from the EU versus Disinfo, but we will also produce a large data set with different languages, different models, generated narratives and counter-narratives, and also evaluation marks. And also the code for the pipeline to effectively like generate, extract and generate.
So to think about offering a benchmark to it?
It doesn't really exist, and
this is why.
Yeah. So yeah, we are, but we need more data for it, and
Sure.
so because this like 1500, it's not benchmark worthy, I feel, but this is something that we can serve. Also, I think our work is the first to tackle counter narratives in Ukrainian and Russian, to our knowledge.
No questions? I still have one. Could you please elaborate on the number of human evaluators?
Each language has been evaluated by 2 people. It's bare minimum, but that's what we could get.
So it's hard to give us as the internet agreement having such small teams per item per language. Did you think about extending?
Yes, but this is something that can be considered for the final thesis, because we are going to run one more experiment, but it's something that needs resources. It's hard.
Oh, I'm sorry for that evidence. Perhaps there are implications and differences between scores of the LLM evaluation and human evaluation. Perhaps if you have a bigger team, this will be a little bit more aligned.
Yeah, I mean, it's 10 people total to per language.
Yeah, I understand that. I understand the difficulties. I understand that this is laborious, but anyhow, how would you do it the other way? Yeah. So we have to think about it. Thank you very much. So. Now I've got that Ruban. With Yurii, Paniv, and Dmytro Chaplynskyi as co-authors. And the title is Training Large Language Models for Neural Machine Translation using Reinforcement Learning Techniques. Floor is yours. What have you had?
Then connect this, right? Hello, my name is Bohdan Ruban. My supervisors are Yurii and Dmytro Chaplynskyi, and today I will present you my expose for training large language models for neural machine translation using reinforcement learning techniques. So neural machine translation is a straightforward task for translating a text from one language to another language, and is typically approached using supervised fine-tuning with maximum likelihood estimation. This often leads to outputs that lack fluency and cultural nuances, especially for languages like Ukrainian, which is morphologically rich and much more complex than English, for example. And some significant NLP progress was made for Ukrainian with the release of LLM model and MAMAI. But still, reinforcement learning has not been quite as well explored as SFT. We may look at the current Ukrainian LLM leaderboard, specifically the translation benchmark Flores. Currently, LAPA is a leader, judging by the BLEU score. And but still, LAPA and MAMAI were not using RL for training. So this direction needs to be explored. Yes, previously there has been efforts in improving performance for specifically translation task in the Dragoman project, which was the project of my supervisors Yurii and Dmytro. And for more high resource languages, there have been efforts in designing rewards and methods that work even without reference translations, which is a quite difficult thing to do. But still, no efforts made for the Ukrainian specifically. The main research questions are, can RL-based alignment improve English-Ukrainian translation quality over an SFT baseline measured by these core metrics? And actually find out which reward signals are the most beneficial and produce the most effective training signals in RL-based machine translation. The initial pipeline is as follows. We need to bootstrap a model, train an SFT baseline on a data set called 55 shades, specifically a subset of around 500,000 instructions, which we selected by quality estimation metrics. And after that, we apply group relative policy optimization. This is a reinforcement learning method introduced by DeepSeek in 2024. So still quite new and still used widely today, basically a standard right now for reinforcement learning alignment. And the main reward signals that we choose are classical BLEU, CHRF signals that I will delve on more deeply later, and actually more new reference-free neural metric Comet Kiwi, which is part of a larger family of Comet models, which I will tackle
later. Alternatively, we may try a newer method proposed by NVIDIA, but this will be in the future. For a baseline model, initially we settled on Gamma 34B because our compute allowed it, and it already had some strong Ukrainian benchmark performance. But larger models such as Lava were tried, as well as a smaller 350 million parameter model, which is also fine-tuned on 55 shades using SFT, called Kulik. Let's explore the evaluation metrics that will also be used as main reward signals. The or bilingual evaluation under study is a metric that counts n-gram overlap between hypothesis and reference, so it requires reference translation and scores between 0 and 100. It has quite strong limitation for Ukrainian, since words that look similar may produce very bad scores because their n-grams do not match. Another metric is a bit less rigid, character score. Measures overlap at the character n-gram level plus word n-grams, which is better for Ukrainian, and it correlates more with the human judgment, but still it needs reference relations. And finally, Comet, specifically Comet Kiwi model. This model has one of the highest correlations with human judgment, and does not need reference translations. So two texts that may use different wordings may have the same score. So we do not rely on using the same wording to produce good translations. It measures it on a deeper level. The datasets, main dataset for the training was chosen to be 55 shades. It's a compilation of 55 million plus translation instructions. And we selected for 170,000 based on a quality estimation metric. And for evaluation, we are using standard benchmarks Flores and WMT. And metrics are, as I mentioned before, YLEU, CHF, and VOT. The research timeline looks like this. Currently, we're at the point of fine-tuning reward signals and finding what works and what doesn't, trying different approaches from other studies that worked for high resource languages and trying to apply it here. And hopefully we will be able to submit a paper for AMLV conference and present it if it will be accepted. As for early results, first I took a smaller model which already has quite a good score for Ukrainian WIC, and fine-tuned it using GRPO, and got pretty good, maybe a bit modest, but still an improvement on all metrics. And yes, the main reward signal is again below CHRF and Comet, which is a combination of reference-free and reference-dependent metrics. And also there are some extra rewards for punishing the model if it drifts too far from desired behavior, like outputting too much unneeded text, writing something in a different language, of course, or producing other non-wanted outputs. And after that, I decided to try a larger model, Lapa, since it has the highest score right now for translation, and got also some good improvements on both directions. So from English to Ukrainian and from Ukrainian to English. But since it's a quite big model for the computer I have available, it's 12 billion parameters. It was trained with lowering adaptation at rank 128. And its adapter combination actually surprisingly did not lose performance for Ukrainian to English direction, but lost like 20% in English to Ukrainian, which is not that drastic. And for WMT, actually the dataset is more aligned with Flores, because Flores contains pairs from Wikipedia, and the dataset I was using was more Wikipedia aligned, whereas WMT is more news, literature, and etc. So it's a bit a different domain, but still I got an improvement over it. And also to mention, it is the models are very sensitive to system prompts, to prompts in general, and generational parameters. And after training with GRPO, it produced more, this results more consistently without system prompts, with more weight system prompt. So here is basically the maximum I could get from a baseline model by tuning the generational parameters and prompts. Yes, if you try a simpler setup, the results will be more impressive, but I don't think it will be fair compared this way. So overall, the current setup produces an increase in BLEU score of about 0.7, 0.8, which is modest, but still good improvement, and it may improve even further for the master series. To conclude, as of recently, neural machine translation is shifting from SFT to RL alignment, and for Ukrainian language, it is unexplored. So we try to tackle this problem by introducing our own pipeline and optimal metrics for improving the performance, which hopefully may also transfer to other low to mid-resource languages. The RL-based approaches are also largely untested. And that's it. Thank you. I will be glad to answer your questions.
Shall we be glad to ask a question? You mentioned like trying different prompts. Have you tried photo prompting or prompt
Could you
generation?
repeat one more time?
You mentioned that you like the results highly depend on prompts.
Yes.
Have you tried like auto prompting or DSPI framework or something?
No, I did not try them. The main issue is bigger models very so sometimes their response varies from system prompt. For example, for Lapa, the score improved drastically when I mentioned that Lapa is a professional translator. You have very good experience and return on the good results. But for smaller models, it may work differently. Yes, I probably should try to make it for questions.
More questions? No. Okay, thank you very much. Next is Kateryna Karpo, backed by Artem, from the bridging the Pavliuk connection about the agent strategies or grammatical error correction with backlogs, language mode.
It's no problem. We have still 5 minutes. Okay.
Hello everyone, my name is Karpo, and I'm working together with Artem. Today I want to talk about a specific problem in grammatical error correction, a phenomenon we call overcorrection, and how a multi-agent prompting strategy can help address it. The title of my position paper is Bridging the Overcorrection Gap. Multi-agent strategy for grammatical error correction with black box large language models. Here is how I will structure the talk. I will start with a brief background on the GAG task itself, then move to how we evaluate GAG systems. From there, I will explain why overcorrection is a serious problem, lay out my research questions, describe the approach I'm proposing, sketch my vision of the solution architecture, walk through the research again, share some early results, and close with conclusions and what comes next. Let me start with the basics. Grammar error correction is a task of automatically detecting and fixing errors in text. Things like wrong verb tense, missing articles, misspelling, punctuation issues, while keeping the author's original meaning intact. You can see a simple example here. The sentence, he go to the library yesterday and read 2 books, contains several errors, and a good GAG system should produce a corrected sentence. He went to the library yesterday and read 2 books. Correcting the mistakes without changing anything else, without paraphrasing or take additional punctuation. GAG has practical application in language learning tools, writing assistance, and multilingual post-editing pipelines. Before we talk about the problem, it is important to understand how GAG systems are evaluated, because the choice of metrics directly shapes what we consider a good correction. We use 2 standard benchmarks, one 2014 test set and BAG 2019 benchmark suite. For analysis, we look at true positives, false positives, and false negatives broken down by error type, and also we study precision recall trade-offs. The 2 main tools are ERANT, which automatically extract and characterize edits, and the M2 score, which compares system edits against human references. One thing worth highlighting about 2019, the test set is closed. The labels are held privately on Codalab, and systems have to submit their outputs for blinded evaluation. This is important because it means no one can overfit to the test set or selectively report results. Every number on that legal board is comparable. The primary metric we care about is F0.5, a weighted F-score that gives precision twice as much weight as the whole. This choice is important in GET. Making unnecessary changes is considered worse than missing some errors. And before I explain the problem I'm addressing, it is important to understand where the field has been coming from. Until very recently, virtually all strong GET systems were fine-tuned sequence to sequence or sequence to edit models like Gector. Gector is transformer trained to predict token level edit operations. It's achieved 73.1 0.5 compared to 2019, which is sort of for a single model right now. And the current fine-tuned state-of-the-art, state-of-the-art is ensemble of 7 such models. Other approaches like fine-tuning BART or T5 follow the same paradigm. You collect thousands or even millions of annotated sentence pairs, fine-tune a model, and repeat whenever you want to improve. The critical limitation of such solution is that all of this requires labeled data, GPU infrastructure, and significant compute time, and also data scientists as well. The right column shows that what emerging prompt-based approach that use black box LLMs models without any fine-tuning. For example, APO from my colleague Artem is the current prompt-based state-of-the-art, and this works. The one I'm presenting today decided to take also this direction by introducing multi-agent decomposition. This is the paradigm shift from training models to correct everything at once to instructing general purpose models with specialized targeted prompts. So why does it overcorrection matters? The core problem is that large language models are trained to be fluent and helpful, which means they tend to rewrite text more aggressively than needed. They introduce changes that aren't errors, so-called false positive changes, and because our main metric F0.5 weights precision heavily, this false positive directly hurts our score. Fine-tuning a model to fix this requires, as I said before, dataset, GPU, etc. And it's a significant barrier. On the other hand, modern LLMs are available through API, which means we can influence behavior purely through prompting. And that give us more opportunities. My work is organized around 3 research questions. The first asks whether decomposition jack into specialized sub-agents, each focused on a specific error type, produced better metrics than a single monolithic prompt. The second asked about optimal granularity, is it better to have a fine-grained agent for all of 25 plus error categories, or group them into broader linguistic buckets? And the third question is about selective conservatism. Can we configure certain agents to be more accurate, to apply fewer but more confident edits in a way that it proves precision without sacrificing too much recall? Yeah, and my central hypothesis is that combining multi-agent decomposition with selective conservatism can narrow the gap between prompt only and fine-tuning JET. Yeah. Here, two approaches: monolithic prompting and multi-agent prompting. Yeah, we investigated between these two extremes. On the one side, a single instructions like correct this text minimally, do not paraphrase, handle everything in one pass. It's simple, but it gives a very little content. And on the other side, multi-agent prompting assigns each error type its own specialized agent, each with a narrow edit scope and tailored instructions. The outputs are then combined through ensembles methods, measure voting or edit margin, and so on. The key insight is that by specializing agents and tuning their conservatism independently, we gain much finer control over the precision to call trade-off. Yeah. Here is one example of architecture that we research. Yeah. Yeah. Input sentences comes in and is sent in parallel to a set of specialized agents. One group handles agreement and tense, another spelling and word choice, another one punctuation and articles. Each agent apply only its type of correction. Their outputs are then passed to an ensemble layer that merges and works on the edits. And the final minimal edits corrections come out. The 3K design principles are configurable pipeline with error type specific prompt per agent, selective conservatism, where high false positive category gets stricter constraints, and also automated prompt optimization using different tools like EPI, APO, or APRO to tune each agent instructions. Yeah, here is our research plan. We decided to have 4 phases. Phase number 1, we will build an extendable multi-agent framework. The scaffolding that lets me configure agents pipeline and assign error type specific prompts. On phase 2, we decided to concentrate on evaluation. We will run monolithic, fine-grained, and grouped agent configuration on our 2 benchmarks and compare them using our main metrics. And phase 3, we will analyze the results by error type, figuring out which categories generally benefits from specialization and which ones remains hard to do correct without overcorrecting. And finally, the last phase applied automatic prompt optimization to each individual agent to push performance further. Yeah, where we are right now, yeah, this result was based results on slides was based on the position paper. So that's not the past results that we already have. Yeah, but for, let's say, February 2026, we completed the literature review, formulated the research question, and set up the evaluation pipeline. as context for the benchmarks number, Vector is fine-tuned. Single model sorter right now has 73.1 on bar, 19 on bar. An ensemble of 7 different sequence-to-sequence model reached 81. And this is fine-tuned state of the art right now. For prompt-based methods, we made our own baseline, and the matrix is 57.5 right now. And our multi-agent target is be announced in another our work. But the key insight reviewing this work is that our collection is a systematic, consistent behavior in LLM, not noise, which makes it can be addressed systematically. More facts about early results. Here is about our baseline problem. As you can see, it's really simple. We decided before building the multi-agent framework to have a simple baseline to understand where we stand for and where we're starting from. The prompt is minimal, as you can see. No constraints on edit scope, no conservatism instructions, just a direct correction request. We received on the test set 57.5 0.5 value. The baseline achieved a recall of 73.3, which tells us the model finds most of the errors, but precision only 54.6 means nearly half the changes it makes are unnecessary. Our results quite far from the fine-tuned state of the art results. This is exactly the overcorrection problem in action. The model is changing too much, and this is precisely what the multi-agent approach is designed to fix. This is conclusions. Let me close with where we stand and where we are going. On the completed side, I've done literature review, formulated research question, etc. We made also baseline to confirm the overcorrection problem. What remains is the main research work, building the multi-agent framework, running the comparative experiments against monolithic prompting, implementing selective conservative per error category, and applying automatic prompt optimization. Thank you for your attention.
Thank you very much. Questions, please? No questions? That's very important. That's grammatical error correction.
I have a question about your next multi-agent framework development in mind. What will you use to voting processes? Will be some kind of agent coordinator between those sub-agents, or how you will evaluate the results of the different sub-agents? Combine.
Here we have something like a vision of our future architecture. We would like to have specialized agents that will work in parallel, and after that we have ensemble, based on voting, and after that we on ensembling we match everything, and as output we expect only one sentence. So one sentence input, one sentence output.
This is a different question.
Oh.
Colleague asked about the communication between those agents that work parallelly. How would they communicate
We
achieve the
decided,
result and merge the final result into that?
yeah, we decided,
How would they vote?
yeah,
Would there be a coordinator agent
yeah.
managing the voting
Yeah,
process?
it would be an architectural agent that will merge everything. Yeah, so we have sub-agents and main
So
agents.
that orchestration
Yes,
as a way to assemble
yes.
activities for the tasks. Why do you need orchestration here?
Because
Why not just coordination? And what is the difference?
the difference between
Orchestration and coordination.
yeah.
The question was about coordination. Was it?
Yeah, about the main coordination between agents. What is the approach?
Yeah, right now they're not coordinated.
Is orchestration a sort of coordination or not?
I think no, but yes and no, because
Could you please elaborate on that?
yeah.
Why yes and why no?
Coordination, I think is
Sorry for cannibalizing your question.
it's between the sub-agents, how they can communicate, which is one each other.
Okay.
And orchestration is something like you have parent agent that will give that will sum up everything from sub-agents.
Okay. Thank you very much. Are you happy? Yeah. Okay. More questions, please?
Do I understand correctly that you actually already implemented this?
Yes.
So what is being presented is kind of as what was at the submission.
At the submission.
Yes. So
Yeah.
all the pipeline is already implemented, and maybe could you please share the current results? What do you have?
I'm not sure because we decided to write 2 additional papers. Yeah, and we already submitted for UNLP one, and we decided to write another one since we achieved really good scores. But these results, yeah, for this approach for multi-agents system, we have negative research. Yeah, because multi-agents give us more overcorrections, give us more false positives added. But approach or single prompt with minimal edits and with batching approach give us really good results comparative to SOTA.
More questions, please? Yeah, thank you very much. This concludes our first session, and thank you all very much for being perfectly aligned with the time. So you have 4 minutes. Now, 1 hour break for lunch. And you all know where to handle that. So this is not covered by the program. We're looking forward to start the next session at 1 p.m. German.